Hello, Assalamualaikum. We are Group 1. We'll present our project which is Green's Theorem. This is our team members. This is the theorem of Green's Theorem. This theorem stated that C is a simple closed curve and D will be the region bounded by C. Hence, to solve the problem by using Green's Theorem, this formula will be used. Double integral will make it more simple in finding the region bounded by simple closed curve. Then, this is the example of simple closed curve. Green's theorem plays a significant role in solving complex line integrals into simple double integrals. Green's theorem can be divided into two forms, which are flux form and circulation form. Double integrals helps a lot in finding the region bounded by simple closed curve in these two forms.
Question 1. Amina bought a robot vacuum during 12/12 sales. She used this vacuum every morning to clean her bedroom. The area of her bedroom was described by integration x squared y dx plus x dy and shown below. By using the Green theorem, evaluate the area that the vacuum cleans every month. Next, for the manual calculation, by the Green theorem, we must integrate f dot product with dr, where integration p dx plus q dy and equals to double integrate q differentiate towards x minus p differentiates toward y dA. The value that can be leased out from the equation are p equals to x squared y, and we differentiate p towards y and we get x squared. Next, q equals to x and we differentiate towards x, we get 1. Next, we have to integrate by the horizontal line. As we know, the Green theorem is integration f dot product with dr, where integrate x squared y dx plus x dy equals to double integrate 1 minus x squared dA. So, for the next step, we have to find the limit for y and for x. So, in this question, we use dA as dy dx. And limit for y from x to 1.5 and limit from x from 0 to 3. So, firstly, we integrate step by step. First, we integrate y and we get y minus x squared y, and we have to substitute the limit and we get 1.5 minus 1.5 x squared minus x plus x cubed dx. So next, we integrate towards x. So we get 1.5 x minus 1.5 x cubed over 3 minus x squared over 2 plus x to the power of 4 over 4. And we substitute the limit, which is 0 to 3. And lastly, we get the final answer is 6.75. Next, for the maple calculation, as below. And we substitute all the coding into maple and we get the same answer, which is from the maple calculation and the manual calculation.
Next, for question 2, the robot vacuum is equipped with sensor that can detect water, preventing it from entering wet areas and ensuring it doesn't clean them. Amina spilled her coffee on the kitchen's floor this morning. Evaluate line integral y squared dx plus 4x plus 3y squared dy, which the area that the robot vacuum can't clean. For manual calculation, we need to identify P and Q first. For this question, P is equal to y squared, while for Q is equal to 4x plus 3y squared. Then, we need to differentiate P with respect to y and differentiate Q with respect to x. Then, we get py equals to 2y and qx equals to 4. Then we need to set up according to the Green's theorem formula, which are double integral qx minus py dA. Then we get double integral 4 minus 2y dA. After that, we can choose to set up the double integral in terms of dy dx or dx dy. For this question, we set up the double integral as dy dx, which the limit for y is from x squared to 4, while limit for x is from 0 to 4. Then we need to integrate 4 minus 2y dy, and we get 4y minus y squared dx. And we need to substitute the y limit, and we get negative 4x squared plus x power 4. Then we need to integrate in terms of dx, and we get negative 4x cubed over 3 plus x power 5 over 5. Then the last step is we need to substitute the x limit, and we get the answer is 1792 over 15. Next, for the Maple calculation, we set up the graph in Maple as above. Then, we use coding in Maple to generate the answer for this question. And the answer in Maple is 1792 over 15, which is similar with the manual calculation. Last but not least, we want to say thank you to Dr. Masna for your time and attention. And I think that's all from us. Thank you.